Hi students, today we are going to discuss SN2Ar reactions as well as Benzyne mechanism. We have done the SN2, SN1, E1, E2. So this is the next very important mechanism of SN2Ar. Okay, apart from SN2Ar, we will understand why chlorobenzene not easily participate in the nucleophilic substitution reactions. What is going to be happen? So both things we will understand. One, additions elimination mechanism, and second, eliminations addition mechanism. Okay, so see here we have chlorobenzene, and chlorobenzene is not easily involved in the nucleophilic substitution reactions. So suppose any nucleophile we want to attack on the chlorobenzene, then the reaction is not easily possible at normal conditions. So what is my question here? Why unsaturated or any such set of compounds we have, either the unsaturated or any such of compounds, not easily involved in the nucleophilic reactions? You can see here also CH2 double bond CH, CH2 Cl, also not easily involved in the nucleophilic reactions at normal conditions. Although it will involve in the nucleophilic substitution reactions, but not in normal conditions. When we supply high temperature, high pressure and a strong nucleophile, then this compound will involve in the nucleophilic substitution reactions. Okay, but what the reason? As we know that because the chlorine contains the lone pair, due to lone pair it will involve in the mesomeric effect. Correct? Due to mesomeric effect, what will happen? There is a partial double bond. Here is the partial double bond happen. Correct now? Due to partial double bond and due to mesomeric effect, the electron density increases ortho and para positions. Right? And partial double bond happen. Since partial double bond means bond dissociation energy will be very high. Bond dissociation energy of this compound will be very high. Why? Because there will be a partial double bond between the chlorine and carbon. So it's very difficult for any nucleophile attack on the center. Done? So you can say that, sir, SN2Ar is not possible easily in the chlorobenzene. Clear? But yes, it's possible at high temperature and high pressure and strong nucleophile. When we will use it, then the possible. Second, what I am telling you, since when the electron density increases in the benzene ring, electron density in terms of negative charge or electrons. So when the negative charge increases ortho and para positions, okay, and by some way, if I reduce the negative charge, how it will be reduces the negative charge from ortho and para positions? By when you attach the electron withdrawing group. So when electron withdrawing group attach these positions, what will happen? The electron withdrawing group take the electrons from the benzene ring, hence the density decreases at these positions, so that any nucleophile can easily attack on the compounds. So what I am telling you, suppose you have this compound, here is chlorobenzene, okay, and here is NO2 attached there. Then it's very easily that any nucleophile can attack on the chlorine positions, and then SN2Ar is possible. So SN2Ar is possible when more and more electron withdrawing group attach on the benzene ring. So what happens when two electron withdrawing group is attached, that is much more easier than the first. So when we take the nucleophile negative, it will be attached much faster than this compound. So suppose one more electron withdrawing group attach here, that will attack fastest than these two. Correct? So it means what I am telling you, if you have a compound like that, chlorine, NO2, and NO2, right? So there the SN2Ar faster than this compound, chlorine, NO2 and NO2, and this is much faster than, here is that, chlorine and NO2, correct? Done? So what I would like to tell you, electron withdrawing group, more electron withdrawing group attach on the benzene ring, hence the electron density of the benzene ring will be decreases, so that any nucleophile can easily attack on the chlorine positions. Because SN2 means what? One nucleophile will come from the back side and second nucleophile will leave the same positions. Already we have done that. SN2 is concerted reactions, correct now? So any nucleophile attack from the back side, one nucleophile or one leaving group will leave the positions, correct? So exactly when the nucleophile will come, then chlorine will leave the positions. So that's only possible when more and more electron withdrawing group attach on the benzene ring, correct? So what I would like to tell you, we have three type of compound strings. Aryl halide is a three type of aryl halide you have. One, those aryl halide which have a donating group is attached. Second, those aryl halide in which electron withdrawing group is attached. And one, there is no electron donating group or neither electron withdrawing group is attached. So let's understand both the logic. See here, we understand here both the logic. What will happen? See, student, we have aryl halide or alkyl halide. Alkyl halide, we have here is three types. One is activating alkyl halide. Second is deactivating alkyl halide. And third is unactivating alkyl halide. See student, activating alkyl halide means what? Which enhance the SN2Ar reaction, which enhance the nucleophilic substitution reaction, correct? For example, here is chlorobenzene. Suppose any electron withdrawing group attach, either the ortho positions, para positions, or ortho para, both the positions. So when electron withdrawing group attach, that is the called activating alkyl, here is aryl halide. Aryl halide. So what happened? Here is chlorine. So now we have one electron withdrawing group attached. That is the called activating aryl halide. Correct? So it means any nucleophile can easily attack on this chlorine positions. Deactivating means what? Deactivating aryl halide means chlorine is here, and suppose you have attached any electron donating group. Any electron donating group attached on these positions, that is called deactivating aryl halides. Clear? And there is no group attached, simply chlorine is there. That is called unactivating or unactivated aryl halides. So aryl halides we have three types. Activating aryl halides is based on, means if you want to form the phenol from this part, then that is called addition elimination mechanism. So if you want to form the alcohol from this area, if you want to phenol from this area, then what happened? This side we apply the addition, elimination mechanism. Correct? Mechanism. In these two parts, we will use the mechanism of eliminations, addition mechanism. Correct? So it means if you want to form the chlorobenzene to phenol, we will use the dog process. Correct? So dog process, what mechanism follow? Elimination addition mechanism. Correct? But if you want to form phenol from the picric acid, means if you want to form the phenol from 2,4,6-trinitrochlorobenzene or from 2,4-dinitrochlorobenzene, then we will use the addition elimination mechanism. So we understand both the mechanism one by one, so that you will understand how phenol can form from this chlorobenzene, means dot process mechanism we are going to understand, and the one mechanism when the n electron with join group attach, then how it will form, what the mechanism is. Both the mechanism we understand here. Okay? Okay. Let's understand. See here. Both the mechanism we understand here. See students. We understand here both the mechanism. One we are going to understand here. First is dot process. Okay, this is called elimination addition mechanism. Additions mechanism, which is also called Benzyne mechanism. Benzyne mechanism. Okay. See here. Students, we have taken the chlorobenzene. Means we understand here how phenol is formed from chlorobenzene. That is dot process mechanism we understand here. So what happens, students? We will take the 2 moles of sodium hydroxide. So first Na plus and OH negative. What happens, students? Directly it's not possible to attack on these positions because there is a partial double bond. I already said here. So that's very difficult to attack the OH group on this carbon group on these positions. So what happens? OH will attack on the most acidic positions. So most acidic is that this is the most acidic positions, as you know. So OH minus attack on these positions, and so that the water will release from this area. And what happened? Here is chlorine there and negative charge, right? So what happens, students? Now, as you know, chlorine also acts as electron. Chlorine will pull the electron as an inductive effect as well as a beta leaving group. So for the stability of this chain, chlorine will take the electrons and will take away. As a result, what happens? There is a positive charge will come. Positive and negative what will form? Positive and negative that things will form. Here, see here. This is called benzyne. What is called? Benzyne. And student, you know the triple bond is very abnormal with the benzene ring. So it's a highly reactive this compound, highly unstable. Benzyne is highly unstable. So from the first step to this state, this is called, what step is? This is elimination state because bond is formed. So since bond is formed, that is called elimination state. Now from the next step, we are going for addition state. So what will happen? Again we will take the sodium hydroxide Na plus OH minus. Students, OH minus either will attack on these positions or either can attack on these positions. But actually we have taken here carbon SC14 isotopes for differentiate between these two positions. Okay. So for differentiate for these two positions, we have taken the isotopes positions C14. So what happened? It will attack on these positions, and so that the bond will form here. That will turn like that. So what happened? here is you can see here O, H, and double bond is there, and a negative charge once more will come. And now, since it is again unstable, so the hydrogens will release and come to these positions. So that what will happen? I write here C O negative, and here is H will come. Okay, this H will come. And now you have taken the Na plus. So what happened? The compound will form like that, ONA, right? And now you have taken the HCl. So HCl, what will happen? NaHCl will remove, and that will form the phenol. Okay? So now after this, from starting here, from these positions, we have, this is called addition part, and from this part, this is called elimination part. Therefore, it is called eliminations additions mechanism or Benzyne mechanism. Correct? Okay? So therefore, we are saying that when the chlorobenzene we have taken 623 Kelvin temperature and 300 atm pressure, we are using an HCl, because from chlorobenzenes it's not easy to form the phenol. It is only possible at high temperature, high pressure, and a strong nucleophile we have taken then. Otherwise, it's not possible. Right? Now we understand here, that is called what the mechanism? Addition elimination mechanism. Okay? Still we understand the addition elimination mechanism. Here is called addition elimination mechanism. So addition elimination mechanism is what? Suppose you have taken here chlorobenzene, okay, and this time student I have taken the NO2 group. So what happened? Any nucleophile you have, any nucleophile here, I write, any nucleophile you have taken, okay, that nucleophile attack on these positions, hence the bond will turn like that. So what happened? Here is the chlorine, and here is the OH group, and here is the chlorine there, right? Now, since the bond is turned towards this side, so here is what will come? Students, the negative charge will come, and now here is the N. So what happened? The bond will turn like that, and here is the OH, and here is the Cl. And O, and as you know, so double bond will form. Here the negative charge will come. Since negative charge will come, it means what? The NO2 group can take up the negative charge. That is the main reason. The book is also saying that why NO2 group is not attached at meta positions. Clear? Because meta positions does not carry the negative charge. Meta position does not bear the negative charge. Means meta positions does not sustain the negative charge, but ortho and para positions sustain the negative charge that will take up by the any electron withdrawing group. So what happened? Now if bond will turn like that, so what happened? Negative and positive will form. So that things will happen here. Here is the OH, Cl, now double bond and single bond O. Okay. So now what will happen? Again this bond will turn here, and here will turn. Now here is that as usual for short time this reaction happened. So what happened? Here is that C OH Cl, and since the bond is formed here, and double bond O, single bond O. So now what happened? There is a negative charge will come because that bond is twisted here, turned here. So now negative charge has come. It means what? As you know, chlorine is better leaving group, so that will leave the positions. Okay, and so that what will happen? See here, OH bond will form, and then double bond O, single bond. Correct? This one is very interesting. What I am telling you, simply SN2 reaction is not possible easily in methyl fluoride, am I right? So because fluorine is a very weak living group, so that's very, very difficult. But in SN2Ar, if I ask you which will involve faster in the SN2Ar, it is very, very interesting. I write here, see, if I write here this compound fluorine, right, and NO2, and then I write here chlorine NO2, I write here bromine NO2, correct? Yeah? So what do you think, fluorine, chlorine and bromine, what will involve faster? This compound will involve faster. Done. But at the same time, if I ask you in methyl fluoride, the methyl fluoride will very weakly involve in the SN2 reactions. But here, in the benzene, that will involve faster because of high electronegativity is there, and the resonance magnetic effect is also. So both effect involved here. That is the main reasons. Okay, so I hope you understood both the mechanism, addition elimination mechanism and elimination addition mechanism. One question, 2-3 questions I discuss with you so that the concept will be clear. Okay, see here what the question is, and you think about what the answer will be. Student, one question is that, see, here is that. Okay, that's very easy question, already came in the J main, and here is that OH group. So the question is, we have taken the sodium hydroxide, one equivalent, and second that the CH3I have taken. Okay, so what compound will form? There is a main questions. Okay, and think about it, what the answer will be. Student, what answer will be, just think about it. Second questions I give you, this is the first. Second is here. Here is that NO2 group, and here is the chlorine. Okay, I have taken that one equivalent of C2H5ONA, and I have heated also, given the heat. And third is, I have taken that one compound CH2Cl, and NO2 I have attached here. Let's take two NO2 attached. And simply I have taken the sodium hydroxide 1 mole. What do you think, what will form? Think about it and tell me what the answer will be. Okay? Okay. Students, simply here what happened, here the product will be CH3ONA, correct? Right? And then the CH3I you have taken. So what happened? The product will form like that, CH3OCH3. Okay. Here is the thing about it. Chlorine is there. C2H5ONA we have taken and heat. So these positions is para positions. So what will happen? Para position will leave this, means there will be the clearly SN2Ar will involve. Correct? And there is clearly SN2Ar will be involved. And what will happen? Here is a NO2 and OC2H5. Correct, ma'am? And here will be chlorine will be there. And here is no SN2Ar strength because the chlorine is not connected directly with the benzene ring. It is connected side chain. So simply SN2 reaction will be the possible. Okay? So what will happen? Here is that CH2 OH, and here is NO2, and here is a NO2. So I hope you understood that both the SN2Ar and as well as elimination addition reaction. So dot process is what? Eliminations, correct? Addition reactions, and one is the addition elimination reactions we have done that. So in the your NCERT both mechanism based questions chemical properties is given. Okay. Okay, students, regarding this topic, any doubt you have, you send me the mail and the number, or any questions you have a doubt regarding this topic, you send me. I will discuss on the next video lecture of this topic, on the basis of this topic, and we will now next video lecture will understand the method of preparations of all the alkyl halide from alkyl halides, means alkyl halides method of preparation we will understand there. okay, with the mechanism. So continue. If you understand perfectly, watch, share, subscribe and like the video. Thank you.